Today we're talking about renaming whole numbers when adding and subtracting fractions. I'm going to go over an example that's in your book. It's in your book on page 250. It involves Warren and Drake. They each had an apple. Warren ate 7/8 of his apple. Drake ate 3/4 of his apple. What fractions of the apples did they eat together? Well, I'm going to actually take these calculations and act them out with fraction bars so you kind of see what the math is doing. Also, I find this hilarious. Look at those guys. They are so happy to have almost eaten 2 apples together. Okay, so we have the equation to represent 7/8 plus 3/4. First of all, I'm going to get out 7/8. You're going to have to pretend this represents an apple, even though it's blue and long and skinny. And I'm going to get out another fraction tower to represent 3/4. Now the first thing you should notice, 4th graders by now, is that those fractions have unlike denominators. So we need to fix that first. So let's take that 3/4 for a second and think about it. We're going to leave the 7/8 over here and we'll get back to 3/4. What you should be doing in your head is thinking, oh, 3/4, I want that to be a denominator of 8s. So what can I multiply fourths by to get 8? I can multiply it by 2. If I do the same thing on the top and the bottom, I get an equivalent fraction. So 3 times 2 is 6 and 4 times 2 is 8. If I actually pull out the new fraction, 6/8, I can actually see that it is equivalent to 3/4. But we already knew that because we are getting so awesome at finding equivalent fractions. So we're going to take this, 3/4 and trade it out for this 6/8. And then we're going to have the original equation, 7/8 plus 6/8. As you should know by now, 7/8 plus 6/8 combine to make an improper fraction of 13/8. Trust me, there's 13 of them. You don't need to count them. But since that's an improper fraction, usually when we want to express our answers, we want to express them as mixed numbers. So we're going to have to go back and revisit the division rule to convert this improper fraction into a mixed number. Here we go. So the division rule is what I use for turning mixed number into an improper fraction. Remember that this thing in the middle called the fraction bar actually means divided by. So this is saying this fraction 13/8 means 13 divided by 8. So I should be thinking in my head 13 divided by 8. And if I actually do the division, what I end up with is 13 divided by 8 gives me, 8 goes into 13 one whole time with a remainder of 5. One whole time with a remainder of 5. Now I've color coded these so you can remind you where all these pieces go when we make the mixed number. The red one is going to represent our wholes, one whole. The remainder of 5 is going to be our numerator, and 8 is the denominator we're using right now. So one whole plus with a remainder of 5, 8. Let's see if that actually works. That means that I should be able to take 5 of these off for 5/8, and then this should equal one whole. Let's see if it does. Boom! One whole. 13/8 is equal to 1 and 5/8. So, to review, we started with 7/8 plus 3/4. We traded 3/4 for 6/8. Then we added 7/8 plus 6/8, and together they added up to an improper number, 13/8. Then we used the division rule to actually figure out what 13/8 would be as a mixed number. 13 divided by 8 is what we have to think because the fraction bar means divided by. 13 divided by 8 gives me goes in one whole time with a remainder of 5, which means that it should equal 1 and 5/8. And here we go, 1 and 5/8. And just because I like doing it, there's the 8/8 as one whole fraction bar. Alright, happy fractions.